All right, today we're cracking open the case file on a tool that's absolutely fundamental to cybersecurity, the Automated Vulnerability Scanner. We're going to look at it as a kind of digital detective, constantly on the beat, keeping our networks safe. So, let's dive in.
You know, people in the industry call these things the workhorses of modern cybersecurity. And honestly, that's not an exaggeration. Think about it. A single company can have thousands, even tens of thousands of computers, servers, and devices. These tools are the ones doing the tireless, heavy lifting, searching for cracks in the armor that a human team just couldn't find on their own. Not a chance.
And really, that's the core problem they're designed to solve, isn't it? Picture this huge, sprawling digital city with thousands upon thousands of doors and windows. How on earth do you check every single lock every single day to make sure it's secure? Well, that's exactly the monumental task these scanners are built for.
Okay, so here's our game plan for this explainer. We'll start with the detective's basic job description, then walk through its 4-phase investigation. We'll look at a few undercover tactics it uses, how different scanners compare, and finally, we'll talk about its known blind spots.
First up, the digital detective's job. So let's get right to it. What is an automated vulnerability scanner, really?
So, if you boil it all down, a vulnerability scanner is just an automated tool. Its whole purpose in life is to systematically sniff out security weaknesses, or vulnerabilities, across computer systems. And that detective analogy? It's spot on. This isn't just random guesswork. The scanner is actually following a trail of clues, looking for hard evidence of weak spots in a system's defenses.
And just like any good detective, a scanner doesn't just wing it. It follows a very specific, methodical process. This brings us to what we're calling a 4-phase investigation.
So here they are, the 4 key phases of pretty much any professional scan: discovery, enumeration, vulnerability mapping, and reporting. Think of this as the entire life cycle, from start to finish. Following these steps methodically is how a scanner makes sure it's being thorough. Now let's break down what actually happens in each phase.
Okay, phase 1 is discovery. I love the analogy here. Before our detective can start checking for unlocked doors, it first needs a map of the entire city. That's what this phase is all about. The scanner sends out a whole bunch of simple pings, which are basically just little "hello, are you there?" messages to see who's online and active. Because, well, it's pretty simple. You can't protect what you don't know you have.
All right, map in hand, it's time for phase 2, enumeration. Now the real detective work starts. The scanner goes to each device on the map and starts rattling the doorknobs, checking for any open ports. Then it kind of peeks through those open doors to see what's running inside. It does this by reading banners, which are like little welcome signs that often announce the software's name and version. At the same time, it's trying to fingerprint the operating system. Is this a Windows machine? Is it Linux? All these clues are crucial for what comes next.
And that brings us to the brain of the whole operation, phase 3, vulnerability mapping. So, the scanner has all these clues, right? The OS version, the software running, the open ports. Now, it takes all that information and compares it against a massive criminal database of known security flaws. You'll hear these referred to as CVEs, or common vulnerabilities and exposures.
And it's really important to get this, it's not just a passive lookup. The scanner actively tests the defenses. If it thinks, based on this version number, that lock might be weak, it'll send a very specific, carefully designed probe to check. It's almost exactly like a detective gently trying a specific skeleton key to see if the lock actually turns. It's confirming its suspicions.
Look, all that amazing detective work is pretty useless if nobody can understand the final report, right? That's why the final phase, reporting, is so critical. The scanner takes all this deep technical data it's found and translates it into a clear, prioritized case file for the humans, the security team, so they know exactly what to fix and in what order.
And a huge part of making that report useful is risk scoring. You'll see something called a CVSS score, which stands for Common Vulnerability Scoring System. Every single flaw gets rated on a scale. So when a security analyst sees a score like a 9.8 out of 10, well, that's not a "we'll get to it next week" problem. That's a drop your coffee and fix this right now kind of emergency.
Okay, so we've got the 4-step process down, but our detective is versatile. It can take a few different undercover approaches to gather its intel, depending on the mission.
There are basically 3 main ways a scanner can operate. First, you have the unauthenticated scan. This is the scanner acting like an outsider, a hacker on the internet. It has no passwords, no special access. Then there's the authenticated scan.
This is where you give the scanner login credentials, basically the keys to the building. It can go inside and get a much deeper and more accurate look around. And finally, you have agent-based scanning. This is like installing a tiny little piece of software, an agent, directly on the machine. That agent is like a permanent informant, constantly reporting back on the machine's security posture. They all have their pros and cons.
Now, just like you have different types of detectives for different crimes, not all scanners are the same. It's all about choosing the right tool for the specific job.
Really, you can split them into two main camps: network scanners and web application scanners. The easiest way to think about it is this. A network scanner cares about the building itself. It's checking the locks on the doors, the bars on the windows, the strength of the foundation, things like ports and operating system patches. A web application scanner, on the other hand, pretty much ignores the building. It focuses on the complex activities happening inside the building, things like cross-site scripting or SQL injection, which are specific to how web apps work.
But for all their power, and they are incredibly powerful, these tools are not magic bullets. They're not perfect, and it is absolutely crucial to understand their limitations, their known blind spots. Here's the thing you have to remember. Scanners can get things wrong. Sometimes they'll raise a red flag for a problem that isn't actually there. We call that a false positive. But far more dangerous is when they miss a real problem, a false negative. This happens a lot with what we call logic flaws. A scanner is great at checking if a lock is broken, but it has no way of understanding the business rules about who should have a key to that lock in the first place. That requires human intelligence, which is why you still need human penetration testers to find those kinds of subtle, context-aware flaws.
And that really brings us to the big takeaway here. Our automated detective is an absolute expert at finding the knowns, the flaws that have been discovered and documented in its massive database. But what about the unknowns, the creative, brand new attacks that nobody has seen before? That's where the automated approach hits its limit, and it leaves us with a really important question to ponder. Scanners find the known flaws, but how do you find the ones that nobody even knows to look for yet?